Hey guys, today we're doing day 2 for 3.6, which is all about, again, graphing quadratic inequalities. For day 2, what we're focusing on is graphing systems of quadratic inequalities. So the nice thing here is that it's not any different in terms of the process. It's just that we literally are just having two graphs, two quadratic inequalities on the same coordinate plane. So my process here is going to look the same as what we had done yesterday. You're going to graph the first inequality, graph the second inequality, and then the solution is wherever those two shaded areas intersect. So I'll show you two different ways on how to do this. If you have the capability of graphing with two different colors, that makes it a lot easier to distinguish between the two. But I will also show you guys an option on how we can handle that using just a single pen, pencil, marker, whatever you use for your graph paper. Or if you're doing it on Cami or something like that, if you don't have the capability of switching colors, which I know that you do on there, but if it's too difficult for you, you just prefer doing it in one color, I'll show you how to shade using just a single one. All right, so let's jump right into one of these. Example number 1. So for both of these, I'm going to go ahead and start the first time around when I graph these and show you what it looks like in two different colors, kind of how I handle this. I'm going to use blue for my bottom one, and then I'm going to use red for my top graph. So let's go ahead and start with the top one since I've got red pulled up here. For this one, x squared minus 3, well, that's just a regular parent graph, but shifted down 3 units. So that tells me my vertex happens right here at negative 3. I can go up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1, and that's as far as that one fits on my graph. So this is a greater than symbol, just greater than. So I should have a dotted line. No worries about extra pay for the sound effects. You guys get that for free. From here, it's up to you on how you want to shade this. If you just are going to use the same pen, like if you have a blue pen and a red pen or a black pen and a blue pen, the way that I suggest doing this, and this will work if you're just working using a single color as well, I shade kind of in all one direction. So I'll put all of my shading for my red graph slanted top right to bottom left, so in that direction. Because then when I switch my color and I graph my blue graph now is negative x squared, so that's just a parent graph reflected vertically. So my blue vertex happens at 0, 0, down 1, right 1, down 1 over 1 on both sides, down 1, 2, 3 over 1, down 1, 2, 3, 4, 5 over 1. This one is going to be a solid line, so it's going to be and since this is less than, I'm going to be shading underneath, which I think I forgot to mention with the red one. I knew I was shading above because it's greater than. So from my vertex, I just shade above that vertex since it's greater than. Here, since this one is less than or equal to, I'm shading less than or equal to, so underneath my vertex. Now when I do this, I shade in a different direction. So you can do vertical and horizontal lines. I like the angled one. It just feels more natural hand movement wise. Plus then you can see here in the middle where I have this cross hatching. I have shading in both directions. I can see that right there is the solution to my system. That's the part where both blue and red are shaded. Now this would also work if you had a single color, because if everything was red and everything was blue, you could still see where that cross hatching happened without needing to see both colors. Okay, so that's how we do it. That's basically it. We'll go through a couple more examples, but that's the long and short of it. All right, for example number 2, box number 3. This one a little more complicated, a little more difficult to find the graph for my top and bottom. Here again, I'm going to do my bottom in blue, my top in red. For my red graph, we'll do some scratch work over here to the side. So I'm going to do x equals negative b over 2a, which is negative 2 over 2 times 1. So negative 1 is my AOS for the top one there in red. So when I plug that back in, I get -1 squared plus 2 times -1 minus 3. And we end up with +1 minus 2 minus 3, which is a -4. So my vertex for that red graph is -1 comma -4. So go ahead and plot that point there. My a value on that top equation is just x squared, or sorry, my a value would be 1 because it's just x squared. So I get to follow my regular 1, 3, 5 graphing shortcut. Here it is greater than or equal to, so it's going to be a nice solid line. And since it is greater than, I'm shading above my vertex. So here, let's try this out. Let's try and actually do some color mixing here. Shady, shady, shady. So here, let's pretend we've got a pen, we've got markers or colored pencils. People like to get artistic with it. Yeah. All right, switching over to my blue graph. A little bit easier to graph in this case because it's just -x squared plus 3. So the plus 3 tells me my vertex was shifted up 3 units. The negative attached x squared just tells me I'm going 1, 3, 5, just down. So down 1 over 1, down 3 over 1, down 5 over 1. That is a dotted boundary since I'm just less than. So dot, 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 dot. Dot, 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 dot. Dot, 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 dot. Arrows on the ends. Now here, because it's less than, I'm shading underneath my vertex. So if I switch over here to coloring in my blue, all of this stuff underneath gets shaded. And you can see it's a very faint purple. It's more red than anything else. But you can see this little section right here where the colors mixed together. That is the solution to my system because that's where it's shaded for both parts. It's solutions to both my red graph and my blue graph. All right. Last one. All right, for the last one, once again, we'll do bottom in blue, top in red. So for my red graph, -2x squared minus 1. Well, the -1 tells me my vertex got shifted down 1. And -2 tells me instead of my 1, 3, 5 shortcut, I'm going down double. So I'm going down 2 over 1, down 2, 4, 6 over 1. And that's all that fits on this graph. It is less than, so it's going to be a dotted line. And since it's less than, I'm shading underneath. So switching over to my blue graph. My blue graph is in vertex form, so this is going to be h comma k is -4 comma 2, -4 up 2. That's my boundary right there. Or sorry, my vertex. I've got a 1 for my a value, so my regular 1, 1, 2, 3, 5 is not going to fit. Shortcut. So it is or equal to, so I'm going to do a solid line. And then since it's greater than, I'm shading above my vertex. So that's going to be all of this stuff. So they don't overlap at all. So this is kind of a funky one, but this is what it looks like when it's no real solution. NRS. There is no overlap between those 2 points or those 2 graphs. There is no solution to that system because there is no possible x and y value that makes both of those inequalities true. And that's it. That's it for this section. That's it for chapter 3. That was the last one we had to do. Your homework for practice for today is page 144, 21 through 26, all, both evens and odds. Because this is the last section, make sure you guys are reaching out and letting me know. Today is the only day we have for 3.6 day 2. Tomorrow, Tuesday, you're going to be working on the study guide for chapter 3 test. Wednesday, we'll be doing a review game. And then this week on Thursday and Friday, you guys will be taking the test. So, as always, make sure if you have any questions, concerns, thoughts, ideas, hopes, or dreams, you guys are reaching out and letting me know so I can help you out as we have time to. And if not, I'll talk to you soon. Have a good one.